And welcome to C++ Bytes. In today's video, we're going to touch on object-oriented techniques and basically learn how to create classes and interfaces and virtual functions, which are functions which you can override in derived classes in C++. So let's get started. So I have a VS Code project. I'm calling it OOP for Object-Oriented Programming. And I have my project and build set up using this .vs code files. You can find the instructions on how to set it up using the description. So I'm going to go ahead and create a file. It's called main.cpp. And this would be our entry point file, which we'll be using. So I'll go ahead and just create the main function here. It's gonna say return 0. This is our basic structure. Let me just go ahead and make sure that it compiles. Okay, good. So now the first thing we are going to do is we're going to start with an interface. So I'm going to create a new file and I'm going to call it drawable.h. So this is what I'm creating is an object-oriented design for, let's say, a graphics program, or something which can represent geometry objects. So you would have an interface called drawable, which is something that could be drawn, and then you can have a shape, which can also be drawn, for example, and then you can have a more specific shape, for example, a polygon or a square, which is a shape and also draws. And then there's some basic requirement for the drawable interface, and then as we would add more inheritance, we would add more specific methods, and then you'll see how you do that in C++. So let's start with drawable. This is a header file, so there's no interface keyword in C++. So if you want to have an interface, basically it's a class which becomes an interface for you. So I'm gonna start showing how you would create a class here. So I'm gonna create a class. It's called a drawable. At this point it's like a regular class. There's nothing special about it, or you can say it's not like a interface, for example, compared to Java. If you have an interface which you cannot create an instance of. So this is the way you would basically create a block. So public colon, basically anything you have after this is public. You could have a private block if you want. If you have private data, you can have a private block. So let's start with this. And I'm not creating a constructor here for drawable, but compiler will add a default one for me. So I'm going to ignore that. And let's say we are going to have just one method, which is called void draw. So we want anyone who implements drawable interface to be able to draw themselves. That's what a drawable is. And the way you make this like abstract method is you add the virtual keyword and then you say equals to 0. What this does is equals to 0 basically means that there's no base implementation for this method. So drawable at this point becomes an abstract base class. You could call it an interface if it doesn't have any other behavior or data. and it's just like an interface. You could call it an interface, but that's what it is. It's a class, but it's an abstract class, and it's a base class, so you can use it as a derived class somewhere else. Now that we have drawable, let's go ahead and add another class. So I'm gonna say, I'm gonna call it shape. Let's call it shape.header. So with shape.h, what we're gonna do is we're gonna inherit from drawable. So shape is a class which implements drawable. So I'm going to use the same keyword class. It's shape, and the way you inherit C++ is you say public and you give the class name drawable. There you go. Now of course it doesn't know what's drawable, so I would have to import it. I'm going to say drawable.h, and now it knows what drawable is. Now we know that drawable requires a method called draw. It's up to us if you want to implement it or not, but let's say every shape has a virtual method called name. So that way we know what kind of shape it is. So we can call its name and it'll tell us, hey, I'm a rectangle, I'm a circle, whatever I am. So I use a string here. It complains, doesn't know what's in a string, so I'm just gonna include string here, and that's it. And that should, and I guess I will have to do using namespace std so that the string is not needed. So this is pretty much a public interface of our shape class. At this point, it is still, you cannot instantiate it because the base method draw is still not implemented. Also, there's no implementation for name, so it's not quite done yet. So the next thing we're gonna do is we're gonna add implementation for name. So I'm gonna add a implementation file, call it shape.cpp. Come here. So even though these files are named like .h and .cpp, they don't necessarily know each other. So you do have to import shape.h here. And so we know that we have one method which is called name, and it's a virtual method, so we don't have to type the virtual keyword in the implementation. What we can do is we can specify the return type. It's a string, and the method is called name, and here's the body. And I can say return generic shape. However, in order to make it a class method, I have to give the class name and this : so that gives it a qualification that name is a method inside the class shape, and this is the syntax if you want to implement a method for a class, for a shape class, for example. So at this point we have a shape class, but we should not be able to instantiate it because we have not implemented the draw method yet. So let's just do a quick test here. I'm gonna say include shape.h, and let's say if I create an object of type shape s. Okay, there you go. And if I compile it, I got the error that says unimplemented pure virtual method draw in shape. That's what it's talking about, is that because it implements, or it's saying I will implement drawable, and there's no implementation for draw, you cannot create an object of this. So let's keep going, and let's say we don't want people to be able to create shapes and we want them to subclass, create a derived class, and then basically have a more concrete class for their type. So what I'm gonna do is, for the sake of this video, let's add another type called polygon shape.h. Let's just say that. So let's say this is my class, and of course I'm gonna say class, same keyword, polygon shape, and it's gonna be public shape. And by the way, the class name and the file name, they don't have to match. There's no requirement. Of course, it does not know where does shape come from, so I'm gonna say shape. And now let's add some private things to this. So let's say we want it to have a private data called sides. We want to know how many sides are in this polygon. Now let's add some public methods. So let's say there is a method, it's called number of sides. It'll tell us how many sides it has, and let's say we want to implement draw, and we also want to implement name. So this would make it, once we implement all this, this class we should be able to instantiate an object of this type and use it. Another thing I want to show here is I mentioned that you get a default constructor, but let's say I want to have another constructor in which you have to specify the number of sides your polygon has. So what I'll do is I'll just add a method which is the same as the class name, and this becomes the constructor. So now we have a constructor which takes an integer. So you can create this class and specify the sides as a parameter. So now that we have the header file done, let's go ahead and create the implementation. So I'm gonna go to the CPP file, and as always I'm gonna include the header file so we know. And let's first go ahead and implement our constructor, because that's kind of something important. And what I'll do is I'll do sides is equal to num sides. This was the member variable which I'm using. So if you create an object, you specify sides, we save it. And let's say we had a method called number of sides, and we'll just return the sides over here. We also have to do the name, because we want to specify. Let's say polygon shape. Could do something different if we want to do a switch case or something based on the number of sides, but that's okay. I think this will do. And then we also want to have the draw method, polygon shape draw. So I'm not going to do anything, I'm not doing any drawing, but that's good enough. So I'm going to save this, and let's go to our main file, and let's try to create one. So I'm gonna, instead of including shape, I'm gonna include polygon shape.h here. So let's go ahead and start using the polygon shape class. So I'm gonna say polygon shape. I have an object 4 sides. I'm gonna say cout, and the total sides, and this, let's just output the name of the shape, and then my key is not working here. Okay, sorry about that. And then we'll say is, and then I'm just gonna say dot number of sides, and we could just do end line at the end to keep it even. Okay, so let's go ahead and try to build this, and I got this error. This is most likely, if you get this error, the files, it's basically saying I don't know the implementation. Where's the implementation of this? And the way C++ works is it tries to take all the files and then compile them. So because we only have main.cpp, it doesn't know about the polygon shape.cpp. It knows about the header files because they're included. So we include polygon shape, which includes shape, which includes drawable, which is kind of the top file. So that's why it knows about all the header files, but the CPP is not included in the build. So if you make this start.cpp, or you can use the list of files you want, then it'll just work fine. So that's what this is. And so now let's go ahead and run main.out, and you can see it picked up the polygon shape, and it's also saying that it has 4 sides. So at this point we basically have the class hierarchy and everything seems under control, kind of how we want it. There is one thing though which I want to show you, is that right now you can create a polygon shape A without any sides, without specifying any number of sides. Now this may be, you may want to block this depending upon your design. Let's say you always want a number of sides for your polygon. So the way you do this is, remember how we talked about the constructor, the default constructor? We don't have it here anywhere, but if you want, what you can do is you can just make the default constructor looks like this. It's just the name, nothing there, but you can just make it private. And we could specify a default implementation if you want, but basically after this, if you go and do polygon shape, hey, it's gonna complain. It's gonna say that, hey, well, let's just say variable generated. Yeah, so here it's saying that you cannot do this because it's private. So that's how you can basically hide or restrict the number of constructors or the type of constructors you want by just using that private public. It's pretty obvious. You can do the same thing in other languages, but that's kind of how it is. Now one more important thing I want to touch upon, because we're talking about classes and objects, and we'll talk about this later in another video, is what happens when the object goes away. So let's not talk about whether it's dynamically allocated or it's on the stack or pointer or whatnot, but let's just say when your object is destructed. However, that happens. Like if you want to get involved, how do you do that? So the way you basically do that is you can start from the top if you want, and let's just add one here. So let's say you have drawable, and you say cout and drawable deleted. So this little tilde which you saw is essentially a special reserved keyword for a destructor, which gets called at the end, right when your object is being taken out. The runtime will do it for you. You can try to do the same thing for shape. So I go to shape here, and let's say I do tilde shape right here. Now if I want to specify body, I'm going to do it here. So let's say shape, tilde shape, and then we'll just say cout, shape deleted, and then line. Well, let's just import because it probably doesn't know. IOStream, and I'll do using namespace std. Now the same thing we can do for the polygon shape. So we're basically covering each one of them. So let's say I do polygon shape, and we can do the same thing in our destructor here. So, and by the way, just like constructor, there's no return type for the destructor because it doesn't return anything. It's just giving you an opportunity to clean up. So I'm gonna do this, and it says I don't know this, so I'm gonna end line. Okay, and I have a problem with the drawable, so let me go there. First, let me fix this. Using namespace std, and may have to do the same thing in drawable. And so, okay, so the build finished, and now if I run the program, you can see how they got deleted. We got all this, all of them got called. If you want to see a more controlled creation, what you can do is you can put this inside curly braces, and then so that way you can control kind of when they are cleaned up. This is right now happening at the end of the program, pretty much kind of when main is out of scope. So let's run this, and so if we run it again, now you can see that our code ran, and then the object got deleted, and then we got done. Now in case you do not know, this is the way it's working is, and we'll talk more about this in our next video when we talk about memory management and object lifecycle. Basically, when you use the syntax, you are creating an object on the stack. So the stack, each method has its own stack where the parameters are pushed, and you can read more about it. But basically, that is where this object is, and it's defined by this lexical scope of these curly braces right now. So once we go out of the scope, that object gets cleaned up. If you were to do it 2 times, it will create 2 objects. First we'll create first, then it'll remove it, then it'll create another one, and then it'll remove it. So that's how it's working. This is not dynamic allocation. We're just creating on the stack and we're popping it off. Once we talk about pointers and dynamic allocation, then there's a little bit of difference in how the constructors behave and how we want to make sure the right thing gets called. But in this case, because they're not necessarily pointers, it's all working okay. So that's it. I just wanted to cover the destructor. We'll talk more about it in detail. This is not the final way you want to do this, but just wanted to show it in this video. Thank you very much. See you next time.